Thank you for waking up the crowd just after the lunch. I will do a raise hand, but it won't be about Tinder, I promise. A raise hand on who is, and you have to raise your hand once. There's only two questions, so it's one or the other. Who is more into decentralized energy or energy? The next question will be who is more into quantum, because those are the two main topics of the conference. So energy? Oh. Quantum? Okay, some of you. So, well, first of all, as the intro, I'm an electrical engineer by training. By education, École Polytechnique of Montreal. This is where I studied very hard, so hard, maybe too hard. By training, I'm an electrical engineer. By experience, I'm an innovation business development, and this is what I do since ever. The trend in my career, too many years to disclose, is innovation, opening, launching new businesses. So I am here like in a candy store. Innovation and quantum, there's not more than that. I'm very, very, very proud to have the opportunity to speak with you today because of, beginning of the career, electrical engineer, maybe end of the career, maybe not today, but in a few years from now, hopefully I'll get up to their quantum. I'm general manager of Pink, and today my goal is to take the next few minutes to present Pink. We can say Pink too, that's okay too. Pink is easier. To explain the potential benefits of quantum for you. Why we at Pink are confident that starting now, and this is the question, starting now will allow you to be more competitive, to be ahead of your competitors with the quantum technology. Pink offers the only industry-driven advanced hybrid platform that integrates quantum and classic computing resources through a unified enterprise-grade interface. There's a lot of keywords there, but hybrid and unified, hybrid, quantum, and classic computing. Pink was established by Université de Sherbrooke from the Institut Quantique of Quebec and Quebec government, MEIE, as a non-for-profit organization with over $100 million funding to date. And we want to change that. We're started knocking at the door of the federal. I don't know if there's any federal representative here, because we are truly coast to coast, from University of Victoria to University of Newfoundland. So we are a Canadian provider solely funded by federal, provincial government to date. Pink's mission is to bridge the gap between advanced computing potential and practical adoption. Ensuring Canadian organizations capture the economic value from quantum technology while maintaining Canadian sovereignty in critical computational infrastructure. At Pink, we really believe that hands-on experimentation is essential to understanding the potential of quantum computing. We enable Canadians to test, prototype, and explore quantum solutions through a combination of advanced hybrid platform and our advisory services, which is quite recent. We've launched advisory services, and we're partnering with many potential providers of advisory services in Canada too. We offer access to quantum and classical computing. We have the only Canada quantum system, IBM System 1, installed in Quebec, in Bromont, 156 qubit. That is a big part of the 100 million invested in Pink. We are the only exclusive provider of that system in Canada. We also offer integrated classical resources, including CPUs and GPUs, to support the hybrid algorithm development and to also offer computing capacity to our Canadian research centers. We offer custom experimentation, which is quite different than many other consulting firms in quantum. We have a production-ready environment with a unified management and security. We have the ability to experiment in isolated configurable workspaces with support for Python-based SDKs like the IBM Qiskit, but it's not the only one. We help enterprise develop their strategic plan and the roadmap development. We support experimentation that is grounded in the real-world problems. We help organizations identify and develop their use cases. That's very important. How do you start in quantum? First is to identify what are the use cases that are relevant, not just for my industry, but for my company. So we help the enterprises. Those are the part of the advisory services that we launched recently. They identify them, select them, and then develop them. And following that, they develop the algorithms that go with them. And to do so, we partner with the ecosystem partners that we have, universities, research centers that are used to work with our infrastructure. We help enterprises building their talent capacity. We talked a lot about that. So building talent, it starts at universities for sure. We must continue to finance and fund the universities so we have more students coming out of the universities. But we need to also make sure that these university students work on real case, enterprise use cases, and hands-on keyboard, hands-on quantum keyboard. So they really have the experience. Through partnership with universities, and I'll explain a bit the list of universities that work with us, and the research centers, and high-tech experts, such as CMC, consulting firms such as Levio. We just announced last week our partnership with the first consulting firm in Canada, Levio. Very proud to say that we now have 18 customers that are using our infrastructure. Most of them are universities, and it makes sense because we're still in the R&D mode. But the industry adoption has started and is growing significantly this year. On this slide, we see that we're really coast to coast. We have University of Victoria on the west side, University of Calgary that is working with us also, and we have Saskatchewan universities. For sure, we have Quebec universities, Université de Sherbrooke. We're initiated from Université de Sherbrooke with l'Institut Quantique, but also we signed, again last week or the week before, we just announced our partnership with Ivado, 5 Quebec universities that will be onboarded into our infrastructure. So I think on this slide we showed that we have 327 users. We're already more than 400 users, and very soon with the Ivado onboarding, we can expect to be close to 500 users on our infrastructure. We also have a very long list of ecosystem partners. I won't name them all, but very important to our heart because we've been born there is District, the Quebec Quantum Zone d'Innovation District located in Sherbrooke, IQ, Institut Quantique de Sherbrooke. Also, for sure, Quantum City, we are working closer and closer with Quantum City. We see Quantum City being very close to us because industry-driven is part of their ADN too, and that's very important for us. So we are working with the research centers, the universities, but our main mission is with the researchers, with the experts in universities and in research centers to make sure that the enterprises will do what it takes to be ready when quantum will be commercially viable. And this is our mission. This is who we are. I just took a few minutes presenting Pink, our value proposition, our services, our ecosystem. Now let's switch to your industry. Quantum computing has potential application across the entire energy value chain, from discovering new materials to solar cells and batteries, to optimizing complex trading strategies. All 6 of these categories matter. And companies like Électricité de France, EDF, E.ON are exploring across several of them. But if you're managing a decentralized energy system, specifically, three of these become absolutely critical: energy storage, grid management, and forecasting. Why is that? Because they represent the computational bottlenecks that are more acute when you're dealing with distributed energy. As you add more solar installations, feeding power back to the grid, more EVs, more wind and solar that you can't control like traditional generation, these problems don't just get harder, they get exponentially harder. The number of possible grid states, the combinations of variables you need to consider, it grows beyond what classical optimization can handle efficiently. And that's exactly where quantum computing could offer the biggest advantage. So let me walk you through what we are learning about each of these. Let's start with energy storage. And this is a use case that is probably very relevant for many of you, because most of you are into energy, if I recall. If you're trying to integrate more renewables and distributed resources, storage is absolutely critical, but it's also incredibly complex to optimize. Think about what you're trying to balance. You want to maximize the economic value of your batteries, while you also can't wear them out too quickly because replacement is very expensive. You need to respond to changing electricity prices throughout the day, but you also have obligations to help stabilize the grid when it needs it. And if you're dealing with vehicle-to-grid scenarios, now you're coordinating with thousands of EV owners who have their own needs and schedules. Classical systems can optimize for some of these factors, but when you try to consider all of them together, the problem becomes incredibly complex. And this is where, again, quantum optimization could help. By exploring millions of possible solutions more efficiently to find better trade-offs between these competing objectives. Now, practical reality is that you can start testing these quantum optimization approaches on simplified version of your real problems. And because of us, because of Pink, we provide both quantum and classical resources in one platform. You can compare approaches side by side and build solutions that use both without needing separate infrastructure. Grid management is where decentralization really changes the game. Traditional grids were designed for one-way power flow. You generate at a few big plants, transmit to substations, distribute to consumers. Not that straightforward, but more straightforward than a decentralized system. But in leading jurisdictions around the world, and increasingly here in Canada, we're seeing a fundamental shift. Solar panels on rooftops feeding back into the grid. EVs that can both charge and supply power back through vehicle-to-grid technology. Businesses with their own generation and storage. Every one of these nodes can be generating, consuming, and storing at any given moment. The challenge isn't just that there are more things to manage, it's that the number of possible configuration grows exponentially. Should you draw from this battery or that one? Should you limit solar here or redirect power there? Classical optimization has to make simplifying assumptions just to solve the problem in reasonable time. And again, quantum computers are designed for exactly these kinds of problems, where you need to explore enormous numbers of possibilities, to find the best solutions. Now, are quantum computers ready to manage grids operationally? Not yet. The technology isn't there yet. But that's exactly why now is the time to start experimenting. Organizations that are getting quantum ready today are testing these approaches, building the expertise, developing the algorithms. So when the technology does mature in 2, 3, 4, 5 years from now, they're not starting from scratch. They are ready to deploy. The last area is forecasting. And this is where data complexity becomes the real challenge. When you're forecasting for a decentralized grid, you're not just predicting total demand anymore. You need to understand what's happening at the very detailed level. What will solar production look like in the specific neighborhood given local weather patterns? How will EV charging behavior change on a Friday versus a Monday? What happens when there's a local event that changes typical patterns? You're dealing with thousands or tens of thousands of data points, they are all interacting with each other in very complex ways. Classical machine learning can find some patterns, but there's a limit to how many variables and how many interaction it can effectively model, especially when those variables interact in complicated, non-obvious ways. Again, what organizations are doing today is experimenting with combined approaches on real problems, testing where quantum algorithms might add value to specific parts of their forecasting. Identify the problem, test potential solutions, build expertise while the technology continues to mature. Let me bring this all together. We talked about pink. We have an hybrid infrastructure, classical computers, quantum computers. I should have said, today we have the most advanced chip, 156 qubit IBM installed in Bromont. In few, I won't say hours, but days, maybe weeks, we will add Pascal, a quantum computer that is already installed in Sherbrooke, so that will allow our research, our users to be able to use more than one quantum capacity. And we will add Anion very, very soon too. And more important, we will also add on our infrastructure the Canadian quantum manufacturers when they'll be ready. So we are in discussions with Merci. We're in discussions with Norcantic, for sure. Norcantic in Sherbrooke, quantum manufacturer, Canadian, Quebec quantum manufacturer, Xanadu, who didn't hear about Xanadu in quantum. The Xanadu from Ontario, and Photonic when they'll be ready in BC. Those are the three main that have successfully also passed the few steps to be certified by the US Defense, the DARPA program. So those are very important. By 2030, when many expect utility scale quantum advantage to arrive for specific use cases, they'll be ready to deploy. The enterprises working with universities must start now. They won't be scrambling to catch up when it'll be the right time. The questions for organizations managing decentralized energy system here, will you be ready? We are ready to support you to get there. Merci. Thank you very much.